Conservation laws. In this module, you will learn about the conservation laws. You find several forces govern any physical phenomena. In these phenomena, some quantities depend on time, but certain special quantities remain constant. The quantities that remain constant with time are called the conserved quantities. The laws that govern these conserved quantities are termed as the conservation laws. We often assume that the gravitational force is the only force acting on a freely falling object. The kinetic energy of the falling object at the highest point is zero, and the total energy is equal to the potential energy of the object. During the fall, both the kinetic energy and the potential energy of the object change continuously with time, but the sum total of the two energies remains constant. This concept that energy in an isolated system remains constant is one of the laws of conservation, known as the law of conservation of energy. Do you remember the blowing up of the space shuttle Columbus? Due to the air resistance during the fall, mechanical energy, the sum total of its kinetic energy and potential energy of the space shuttle, is not conserved. However, in this situation, the total energy of the space shuttle is constant as the potential energy is transformed to other forms like heat, light, and sound energy. Here you saw the total energy of an isolated system remains unchanged. This also implies that the law of conservation of energy is valid even across the microscopic phenomena. Earlier, scientists thought matter to be indestructible. Due to this, the law of conservation of mass was considered as one of the basic conservation laws. The belief remained strong until the advent of Einstein's theory of relativity that defines the mass-energy equivalence, that is, the concept of conservation of mass into energy, and vice versa. The various conserved quantities in nature may be scalar or vector. For example, an electric charge, which is the random transfer of an electron from one place to another in a region, is a conserved scalar quantity. Thus, this implies that the charge is never created or destroyed. The vector quantities, such as the total linear momentum of a moving train and the total angular momentum of a spinning top, are conserved quantities in an isolated system. Studying two billiard balls, you find the initial momentum and the final momentum of the two-body system before and after the collision are equal, as well as the initial and final energy before and after the collision are also equal. Thus, a conservation law is a mathematical identity to certain symmetry of a physical system. The conservation laws are called symmetric when they are valid for an event irrespective of its time and location of occurrence, assuming the other environmental conditions remain constant. These symmetries play a significant role in modern theories governing fundamental forces in nature. In this module, we have learned conservation laws are the laws that govern conserved quantities. The law of conservation of energy states that energy is neither created nor destroyed. It only changes its form. The law of conservation of charge states that the overall quantity of charge is conserved. The total linear momentum and total angular momentum are conserved quantities in an isolated system. Symmetry of conservation laws means that conservation laws remain valid irrespective of the environmental conditions.